handling more than 37 million TEU each year, powered by thousands of automated container cranes and built entirely on reclaimed land at Seaport of Singapore, stands as one of the world's largest logistics hubs. How did Singapore transform the ocean into a global logistics center? Why is Tuas Port considered the most advanced automated port on the planet? From land reclamation and soft soil treatment to AGV systems and AI-driven operations, how was everything built? Let's explore the entire process behind this engineering marvel. handling more than 37 million TEU each year, powered by thousands of massive container cranes and built almost entirely on reclaimed land at sea. Tuas Port is not just an infrastructure project, but a clear demonstration of humanity's ability to overcome natural limitations through engineering thinking and long-term strategy. What is remarkable is not merely its scale, but how an empty stretch of ocean with no foundation and no land could be transformed into one of the world's leading logistics hubs. To understand the true value of this project, we must begin with the very pain point that led to its creation. For many years, Singapore has been one of the most critical nodes in the global supply chain. Yet its fragmented port system led to rising operational costs, complex internal transport, longer container handling times, and an increasing risk of congestion. As a small country with limited land area, Singapore could not expand in the traditional way while global trade demand continued to grow. Without a breakthrough solution, the nation risked losing the competitive advantage that underpinned its economy. Then that solution emerged. Instead of expanding piece by piece, Singapore decided to build an entirely new megaport, more modern, larger, and more efficient, directly at sea, where no infrastructure had previously existed. However, the gap between concept and reality was enormous, requiring a complex, long-term, and highly challenging construction process. The project began with geological and hydrological surveys to fully understand seabed conditions, currents, and environmental factors, as even minor miscalculations could lead to serious consequences when constructing heavy structures above. This was followed by land reclamation, where millions of cubic meters of sand were dredged offshore and pumped into the construction area layer by layer, gradually forming new land rising from the sea. This was the most fundamental transformation, the direct conversion of ocean into land. But newly formed land does not mean stable ground. Marine soil is inherently weak, prone to settlement, and unable to bear heavy loads. Therefore, ground improvement became a critical phase. Vertical drains were installed deep into the soil to accelerate water dissipation. Surcharge loads were applied to pre-compress the ground, and deep cement mixing technology was used in key areas to reinforce the foundation. This process took months, even years, just to ensure the ground was strong enough for the structures above. Once the foundation was stabilized, construction extended outward with the installation of key walls using massive prefabricated concrete caissons. These were transported by barges and precisely placed on the seabed, forming a continuous and linear berth system. At the same time, navigation channels were dredged deeper and wider, allowing large container vessels to enter and exit efficiently, completing the port's core structure. Behind the key infrastructure was rapidly developed, including vast container yards, straight internal road networks, and fully integrated systems for power, lighting, and drainage, all built to the highest standards. However, what truly sets Tuas Port apart is not just its concrete or steel, but the level of automation and technology embedded within it. Massive ship-to-shore cranes line the berths. Automated yard cranes operate within container yards, and most notably, autonomous guided vehicles. AGVs move along pre-programmed routes, creating a continuous, precise, and highly efficient transport flow. There is no longer chaotic traffic or heavy reliance on manual labor. The entire system is centrally controlled through software and artificial intelligence, optimizing every movement down to the smallest detail. Before entering full operation, the port underwent rigorous testing phases, from individual equipment validation to full system integration trials, ensuring that every component worked in perfect synchronization without failure. And when the first container ship finally docked, marking the transition from testing to real-world operation, the entire system proved its effectiveness. The final result is not just a new seaport, but a global logistics hub that reduces transportation costs, accelerates cargo handling, and strengthens Singapore's position in international trade. From an empty stretch of ocean to a modern megaport, Tuas Port demonstrates that with strategic vision, persistence, and technological application, humanity can overcome what once seemed impossible. More importantly, this project does not merely solve a present-day problem, it sets a new benchmark for how nations will build infrastructure in the future.